Hello friends, I am Nandakishore Suryavanshi from Department of Industrial Chemistry, Arts Science and Commerce College, Chikaldara. Today we are going to see the unit operation drying. Let's first see what is drying. Drying is an unit operation in which moisture of a substance is removed by using heat or thermal energy. During drying, mass and heat transfer occur simultaneously. Relatively small amounts of water is removed, while in case of evaporation, relatively large amount of water are removed from solutions. Now let's see different types of moisture content. First, moisture content on weight basis. It is the ratio of weight of moisture to the weight of wet feed material. If X is the kilogram moisture associated with 1 kilogram of dry solid, then moisture content on weight basis is equal to X upon 1 plus X. Now, moisture content on dry basis. It is the ratio of weight of moisture to the weight of dry solids present in the wet feed material. If the feed material contains X kilogram moisture and 1 kilogram of dry solids, then moisture content on dry basis is equal to X upon 1 and hence equal to X. Equilibrium moisture content. When a wet solid is exposed to a continuous flow of fresh gas containing a fixed partial pressure of P, the solid will either lose moisture by evaporation or gain moisture from gas until the vapor pressure of the moisture of solid equals P. The solid and the gas are then said to be in equilibrium and the moisture content of solid is termed as equilibrium moisture content. Bound moisture content. It is the moisture content in the substance which exerts a vapor pressure less than that of pure liquid at the given temperature. Unbound moisture content. It is the moisture content in the substance which exerts an equilibrium vapor pressure equal to that of pure liquid at same temperature. Free moisture content. It is the moisture content by the substance in excess of equilibrium moisture content. Critical moisture content. The moisture content of material at which constant rate period ends and falling period starts is called as critical moisture content. Constant rate period. It is that part of drying process during which the rate of drying expressed as the moisture evaporated per unit time per unit area of drying surface remains constant. Falling rate period. It is that part of drying process during which the rate of drying varies with the time and instantaneous drying rate expressed as amount of moisture evaporated per unit time per unit area of drying surface continuously decreases. Drying equipments. Equipment in which drying operation is carried is called as dryers. Dryers are classified into two types. Direct dryers. In this, heat transfer is carried out by direct contact between wet solid and hot gas. Indirect dryers. In this, heat is transferred to wet solid through metal surface. Now let's see different types of dryers. First, tray dryer. It is the simplest batch operated direct type of dryer and also known as cabinet or compartment dryer. It consists of enclosed insulated cabinet in which number of removable trays are placed on one another. It is provided with inlet and outlet connections for air. The heating coil, either electrically or steam heated, are also provided. The air inside the dryer is circulated with the help of a fan fitted at the top. The material to be dried is spread over the trays. The trays are put in the cabinet and then the cabinet is closed. The coils are heated and the fan is started. The air is thus circulated and comes in contact with the wet solid. The moisture from the wet solid is thus evaporated and gets added in the air. Finally, the air is allowed to leave the cabinet through an outlet. This is continued until the solid is dried. The dried material is then removed and the new batch of the wet solid is loaded for the next operation. A typical tray dryer is as shown in the picture. Advantages of tray dryer: cheap and easy to construct, low space needed, easy to clean, and low maintenance. Disadvantages of tray dryer: high labor cost, long drying time required, small quantities are handled. Now let's see drum dryer. It consists of an internally steam heated drum which rotates at about 1 to 10 revolutions per minute. The drum is of usually 0.6 to 3.5 meter in diameter and 0.6 to 5 meter in length. The drum is submerged into a pool of solution or slurry contained in a trough. An agitator is provided in truck to avoid settling of solids. A spreader is fitted on one side for regulating the thickness of the film of substance and a knife is fitted at other side to scrape the dried material. A vapor hood is also provided at the top of the drum for collection and removal of moisture. The internally steam heated drum dipped in the slurry revolves and picks up the feed which retains on the drum surface as a film. The thickness of the film is regulated by a spreader. During the revolution, the wet material is heated and gets dried due to heat transfer from steam through metal wall of the drum. As it reaches other end, it is scraped by a knife. The moisture evaporated from feed material goes to the hood at the top and escape. Drum dryers are commonly employed for the materials to obtain in a continuous sheet form such as paper and cloth. A typical drum dryer is as shown in the picture. Advantages of drum dryer: operating cost is low, suitable for slurries or pastes. Disadvantages of drum dryer: capacity is low, not suitable for solutions of salt with limited solubility. Now let's see rotary dryer. Rotary dryer is a directly or indirectly heated dryer used for drying of free-flowing granular material on a large scale. It consists of a hollow cylindrical shell of diameter 1 to 3 meter and length 3 to 30 meter supported on rollers so as to rotate. Inside, the dryer consists of flights which lift the material. The cylindrical shell is rotated by gear mechanism with the speed of 2 to 25 rpm. The cylindrical dryer is provided with inlet, that means a hopper, and outlet for the wet and dry materials respectively. A heater is also provided to make the entering air hot. The material to be dried is fed from the inlet hopper which falls in the dryer. This material is lifted with the help of flights and thus come in contact with hot air coming from opposite side. The moisture from the wet material is evaporated and thus get added in the air. Finally, the air leaves the dryer. The dry product is then taken outside. Advantages of rotary dryer: moderate drying time, low capital cost, high thermal efficiency. Disadvantages: high structural load, product deposition on walls, difficulty of sealing. Now let's see fluidized bed dryer. It is also known as fluid bed dryer. Fluid bed dryer consists of a fluidized bed system and a fluidized chamber. It is provided with a hot air source and a cyclone separator. Feed inlet and product outlet are also provided. The fluid bed is perforated, that means having small pores, so as to pass hot air through it. Wet feed is admitted at the top of the bed through a hopper. At the same time, hot air is distributed at the bottom of the bed through the pores. The wet material and the hot air come in contact in the cross flow to each other and thus the wet feed gets dried. Drying and cooling takes place in the same bed. The product is taken outside near the bottom. The moist air from the dryer contains fine particles of the solid, so before discarding, this air is passed in the cyclone separator, where these fine particles are separated and air is passed out. Fluid bed dryer is used for drying very fine size free flowing materials. A typical fluidized bed dryer is as shown in the picture. Advantages of fluidized bed dryer: easy maintenance, high heat transfer rate, uniform drying, suitable for heat sensitive materials. Now let's see spray dryer. It is a continuous direct dryer used for drying of solutions, slurries and pastes. The essential components of these dryers are a drying chamber with conical bottom where feed is contacted with hot gas or air, heater for heating fresh air sucked by fan or blower, cyclone separator for dust separation, conveying duct and blowers. The dryer is also provided with spray nozzles to spray the wet slurry, solutions, etc. with the help of high speed rotating disc. The feed is pumped through the top of the dryer where it is sprayed into small droplets by an atomizer. The large quantity of fresh air is taken in by a fan. It is then heated in heater and finally fed below the atomizer in the drying chamber. As the surface area of drops is large, the liquid part present rapidly evaporates and gets completely dried before reaching to the bottom of drying chamber. The dried product is then taken out and conveyed to cyclone collector 2 by stream of air. Major portion of the air is taken out through air outlet duct, mostly contains dust, and is sent to cyclone 1. The air from cyclone 1 still may contain some dust and therefore is sent to cyclone 2 for further separation. The air from cyclone 1 is then thrown in the atmosphere by blower. The dried product from cyclone 2 is collected in dry product collector. Heat transfer in dryers. Drying of a wet solid is a thermal process. It is complicated by diffusion in solids or through a gas. Wet solids can be dried by exposure to highly superheated steam. Most of the dryers are designed on the basis of heat transfer coefficient. Drying of porous solids. The flow of liquid through porous solids does not satisfy the solution to diffusion equation. Moisture flows through porous solids by capillarity and to some extent by surface diffusion. A porous solid contains a complicated network of pores. At the surface, various sized pores mouths are present. As vaporization starts, meniscus across each pore is formed which sets up a capillary force by interfacial tension between the water and the solid. The capillary forces are in the direction of perpendicular to the surface of solid. These forces pull the water towards the surface of the solid. Small pores develop greater capillary forces than the large pores. As the water at the surface is removed, large pores are emptied first. Rate of drying curves. Drying characteristics of wet solids can be described by the drying rate curves. Consider that the wet solid with initial moisture content x1 are exposed to air of constant temperature and humidity. If we then measure the moisture content with the temperature, then the curve is observed as curve A. The curve relates the moisture content on dry basis with time. It is clear from the curve that moisture content of the solid decreases with the time and after some time it remains constant, and which is equilibrium moisture content. From this curve, another type of curve can be drawn which is known as rate of drying curve. This curve is much more descriptive of drying process. The rate of drying gives the relationship between rate of drying expressed as the moisture evaporated per unit time per unit area of drying surface and moisture content on dry basis. This curve can be constructed by measuring the slope of tangents drawn to the curve at various values of moisture contents, then calculating the rate.